Hi, this is Randall Restley, Vice President of Applications Engineering here at DigiKey. And I've got a special guest here this week from Fluke, Mr. Tony Shocky. And Fluke is a company that all of us know. I've known it for a long time. I've known it as a meter company, but they've got an incredible wide range of products. And one of the things that I learned that Tony is a thermographer. What is a thermographer? What do you do as a thermographer?
It's a great question, Randall. And to your point, Fluke's been around 70 years, traditionally known as a digital multimeter company, but we do far more than that these days. And thermography is one of those areas where we started just over 15 years ago, and now we're actually one of the world leaders in bringing people solutions from a thermal standpoint. Thermal imaging as a whole has been used more traditionally on what you would call the MRO side of the business. Maintenance, repair, operations,
Yep.
Things like that.
Factory floor.
Yeah. So you're looking at motors, you're looking at pumps, you're looking at electrical, you're looking at electronics a little bit from a PLC or a DCS kind of more traditional control system setup. Now people are actually using this, and this product and technology is migrating into electronics more and more rapidly in aerospace and semiconductors. Anywhere anybody is using a printed circuit board, they can use a device such as this or this here, any form factor with good enough resolution to be able to identify an issue on a printed circuit board. You've got a hot trace, you've got high resistance, you've got components in two channels. Channel 1 looks like it's a little bit warmer than channel 2, yet they're supposed to be acting the same way.
Yep.
Now you can identify that, hey, one's not acting the way that we thought it was or engineered it to be. We need to take a look at that.
So you had mentioned thermography and traces and printed circuit boards, and I'm always used to taking a thermocouple and plugging it into a Fluke meter, but this is more than that, right?
That's correct, yeah. So people traditionally would take a thermocouple, an RTD, a thermistor, something like that,
Yep.
which is a contact temperature measurement device. Now, when you're dealing with incredibly small components such as surface mount technology, when you put that bead of that thermocouple onto that device, you actually create a heat sink on that device. Therefore, you're getting inaccuracies in measurement, or can. The nice thing about thermography in this application is that you're now taking a look at this from a non-contact perspective. You're not doing anything other than looking at the radiant energy coming off a component or an area on a board, which then can, really lead you into an area of where do I need to place that thermocouple, if it makes sense to run it through one of my processes to make sure that you can validate that everything's working properly.
So it sounds like as things have gotten smaller and smaller, it's even more important not to make a heat sink out of your instrument, and this is the way to go.
Exactly, and heat sinks are another one of those areas where you really want to use this technology.
Sure.
I remember here not too long ago working with a customer at a company, and you know what they were using as a thermocouple or a temperature measurement device? Right here, their finger, yeah? How many of you have done this? I mean, it happens everywhere I go. I ask the question and they say, oh yeah, I've looked over here with my finger, and you can tell some heat, right? We have sensors built into us, and that's great. However, it's not going to give you accurate measurements. And the other problem is that there's no USB port on the side of your head for me to extract that temperature measurement data from your finger.
Yep.
So what happens here is you've got the ability now to look at this non-contact, see an entire picture, right? And a picture is worth what?
Yeah,
1,000 words, exactly. So it can really tell you a lot of tremendous detail in a very short amount of time to help you understand what's going on with your process. And you can't actually measure with your finger. You can't actually do a good measurement with an IR gun, which is a more traditional way to measure as well. An IR gun has a distance to spot ratio that is not very effective when you're looking at a very small area. So typically you get a IR gun that is 10 to 1, 12 to 1. You're looking at from 10 to 12 inches away, you're looking at a 1-inch diameter area and taking an average measurement. Well, if you've got 50 components on that particular board, you're taking an average temperature. You can't get any accuracy there. So you want to use a camera so you can identify and pinpoint those areas that are of real value to you, and then get the accuracy there, so you're not adding additional information there with the thermocouple or the RTD or whatnot on the actual board.
So the thermal devices are a focus of Fluke, but of course there's a much broader line of products, yes?
Yes. Yeah, so from Fluke as a whole, you've known us traditionally as a digital multimeters,
Yep.
benchtop meters, calibrators, things of that sort. We make everything from top to bottom now. So if you think of a customer, you think of somebody who's looking for a solution for their entire facility. Whether you're a design engineer, whether you're in operations, you're in maintenance, you're in the facilities portion of of the business, we have something for you. We've got anywhere from earth ground. So earth ground is incredibly important for every facility, because if you don't have earth ground in your facility, you're going to have items that are going to shut off, or they're going to trip, or there's going to be potential additional cost due to power quality issues, things like that. And then we can also measure the power quality issues. So power quality has become a bigger and bigger deal. Yep. Sometimes companies actually get dinged from the power company for thousands and thousands of dollars per month if they have poor power quality in power factor. That's correct. And we can measure and quantify that, and then put you in the right direction for some sort of a solution that then saves you that time and money on your particular equipment.
So it's really everything from building size to board size. The whole range, Fluke is serving that market.
Exactly. So yeah, anywhere from traditional digital multimeters, clamp meters, what we call service and installation tools, to more analytical and diagnostic tools such as thermal cameras, process meters that will actually help you control, understand, and troubleshoot process pressures, temperatures, flows, liquid levels, things like that. On up to things like mechanical. So we've got vibration equipment today that will actually measure the vibration of a bearing, of a motor, of an entire system that's rotating, to understand its life cycle and where it is in that bathtub curve.
State of health of rotating machinery and all, very neat.
Exactly.
So I've got one more question, product question, and that is the T6 meter. This is a pretty revolutionary meter. I'd like to know how you sense both voltage and current without any contact. I know it has to be calibrated, but can you give us a clue into some of that technology? I think that's a little trade secret there.
Well, if I told you, I'd have to, oh yeah, no, I can't go there. But it's a fantastic technology Fluke's been working on for some time. So as all of you know, a clamp meter is a traditional device for clamping around a current conductor and picking up what that current value is. Whether it's AC or DC current, we've been able to do that for decades now. But the ability to measure non-contact voltage has really been something that we've been striving to get to for years, and we've hit this. As of last year, we got to the point with the technology where the accuracy was where Fluke really wanted to be. One of the things you'll typically get much higher accuracy out of the Fluke products than you will in other lines, because we pride ourselves on making sure that when you're dealing with electronics, electricity, and things of that nature, safety is a big and important part for Fluke. I often tell people I don't sell products for Fluke, I sell them safety. Safety comes in yellow, and that's really what we're looking at here. But this tool here allows you the ability to not have to put your test leads, talking about safety, onto a device and make a physical connection to actually get information that you need and are required to grab. So it can save time, effort, and energy when grabbing that data that may be very...
So how low a voltage can you use the meter on? Is it more mains or is it lower?
Yeah, so typically you're looking at more traditional 110 volts and above. Now, of course, it'll go much lower than that. But on the voltage side, you're looking at the AC side of the business there with the T6, which is a huge win, because in most industry, AC is what we're working on. So the MRO side, they're working on 480, 600 volts, up to 1,000 volts with our equipment, and it's all rated for that, anywhere from a Category 2 to a Category 4 rating, which is fantastic.
Great. So, well, Tony, thank you very much. You know, customers can contact Digi-Key for technical support, where they're 24/7, 365. I think also, though, that Fluke offers some technical support as well, yes?
Absolutely, yeah, thanks for asking. So we have a dedicated line at Fluke. So you can go to fluke.com for all the information to go online. But if you want to call in, we do have people standing by. They are in the Everett, Washington area. There are 5 or 6 of them with more than 100 years of experience at 800-44-FLUKE. So that's 1-800-44-5853.
Great.
So it's a great service there. They know about the products, the applications, and the software. Feel free to give them a call.
Great. Thank you, Tony. And thank
you
you for watching.